some of the first couple of chapters are a little bit of review from last year. So this section of ratios and proportions, you've covered this before, so we'll brush through it, quick review on it, and it just kind of gets expanded into solving equations in the end. That's the only really big thing we add on to it. But a ratio is a comparison of two numbers by division, and we can write a ratio a couple different ways. And for example, like our classroom, I can write a ratio comparing girls to boys, for example. And let's say we had 12 girls and 8 boys. So one way I could write that is just writing it 12 to 8. If I wanted to do girls to boys, I could say 12 to 8. And the one thing about ratios is we always write them simplified. So I wouldn't write 12 to 8. If I think about it, 4 goes into both numbers, so I can divide each by 4. So it's really 3 to 2 when I simplify it. So that would be the ratio of girls to boys, 3 to 2. And then we could also write it with a colon, 3 to 2. But today, we're going to use division. So we're going to write it as a fraction. All ratios can be represented as a fraction or with division, right? So that's what we're going to use, ratios as a fraction. A proportion is basically having two ratios equal to each other or two fractions equal to each other. So for example, I have one right here. I did 12 over 8, and that's equal to 3 over 2. That is a proportion. Two fractions or two ratios that are equal to each other. And a couple ways you can check those. The one way we did just by simplifying it there. And the other way is what we do is we take the cross and do the cross product. Some of you may know this already, but you basically multiply crossways, right? Product means to multiply. So I'm going to multiply the 12 times the 2, and I'm going to multiply the 8 times the 3. And then we'll set those two equal. So 12 times 2 gives me 24. And 8 times 3 gives me 24. And we set those equal. Well, does 24 equal 24? Yep. So we know that they're proportional. As long as this checks out, the cross product checks out, we know that they're proportional. So that's what we're going to do here to see if these ratios are proportional. It says use cross products to determine whether each pair of ratios forms a proportion. So basically, we're checking out to see if 0.25 over 0.6 is equal to 1.25 over 2. And we're going to take the cross product. So like we just talked about, multiply crossways. So I got to take 0.25 times 2, which gives me 0.5. And I'm going to set that equal to 0.6 times 1.25, which is 0.75. And so these do not equal, so I would say, no, these are not proportional. Those two numbers are not proportional because their cross products do not equal. Same thing for number 2. I'm checking to see if these two guys are equal. So I take the cross product. So 2 times 20 gives me 40. And I'm going to set that equal to 2.5 times 16, which also gives me 40. So yes, that checks out. So these are proportional. These two numbers would be proportional. So if the cross products work and they're equal, then they are proportional. So we can use that rule now. To solve proportions. So we're going to solve each proportion, if necessary, round to the nearest 100. So now I can use that cross product rule to solve a proportion. So I got n over 12 equals 3 over 8. Well, n times 8, but usually we write that as 8n, right? 8 times n times 8. And then I got to set that equal to 12 times 3. So 12 times 3 gives us 36. And now it's just like we've been doing before. Got to get the n by itself. So the inverse of multiplying by 8 is dividing by 8. Whatever I do to one side, I do to the other. 8's cancel. N equals 4.5. Done. So use that cross product rule. Same thing with the next one. You just got to be careful here. And I'll show you the one part where you got to be careful. So when I take this x plus 4 times 4, I'm really taking 4 times this whole thing. So 4 times that whole thing. So don't forget to put it in parentheses, right? Because I'm taking 4 times the whole thing. I'm going to end up needing to distribute. And then we take the cross product of the other one and set them equal. So 3 times 12 is 36. So if you notice, 4 times this whole thing means I have to distribute that 4. So it's really 4 times x plus 4 times 4, which is 16. And now I can go through and solve. So do not forget to distribute there. So subtract 16 from both sides. And we bring down our 4x, bring down our equal sign, and 36 minus 16, and divide by 4. So x equals 5. Done. All right, so do not forget to distribute. Our last thing, rates and unit rates. Well, a rate is having 2 different units of measurement. So a ratio between 2 different measurements. So miles per hour is like the most common rate. So if I went 140 miles in 2 hours, that would be a rate. So I can write that as 140 miles in 2 hours. Well, if I divided these two, I could find out how many miles I drive in 1 hour, or miles per hour, right? So that unit rate is finding it per 1 unit. So I can take that 140 divided by 2 and find out that I drive 70 miles per hour, or the common label for that is MPH, right? Miles per hour. So unit rate is per 1. You just divide the 2 numbers to find the unit rate. So that might be in one of your story problems. This story problem, we're going to deal with a ratio here. So the gear on a bicycle is 8 to 5. 8 to 5. This means that for every 8 turns of the pedals, the wheel turns 5 times. Suppose the bicycle wheel turns about 2,435 times during a trip. How many times would you have to crank the pedals during that trip? Well, there's a couple ways we could go about this to solve. The one way, since we're dealing with ratios and proportions, let's do that. Anytime I have a ratio, so for example, my ratio of 8 to 5, remember I can write that using division. Just because it's using a colon up there doesn't mean I have to use it that way. I can write it using division. Well, that ratio of 8 to 5 should be proportional to the wheels and the pedals turning. So for example, I could set that equal to another fraction, another ratio, using an amount that actually occurred. Well, I got to figure out where should I put this 2435. Should I put it on top or bottom? Well, if I think about it, this 8 stands for turns of the pedal, where the 5 stands for the wheel turns. So they should match up. So the pedal turns are on top, which we don't know, because this says bicycle wheel turns, right? The 2435 are bicycle wheel turns. So I got to keep the wheels on the bottom. So 2435 goes on bottom. Well, since we don't know what's on top, or we don't know how many pedal turns, give it a variable. I'll use x. You could use p for pedal, I suppose. I just use x most of the time if I don't know something. And now I can take the cross product just like before. So anytime you're given a ratio, you can always set up a proportion. You can set 2 ratios equal to each other. So here we go. 5 times x gives me 5x equals 8 times 2435, which gives me 19,480. And to solve for x, we divide by 5. The inverse of multiplying by 5. So x equals 3,896. Make sure always have a label for story problems, and we're asking for pedal turns. Pedal turns. There we go. So setting up a proportion, using that cross product to solve.